reached 56 meters per second. So, this one I hope you got. U is 0, V is 56, if you take down as positive. A is 9.81, and T is what I want. So let's just pop that down. U is 0, B is 56, A is 9.81, T is what I want. What formula could I use? U plus
B
C.
equals U plus 80.
Yeah, oh yeah. B equals U plus A T.
Yeah.
So what did you get for T?
5.
Not bad. We'll go with that. Seconds. Right, part B. Part A. He opens his parachute and goes from 56 to 1 over 6 seconds. What's the drag? So he's fallen at 56. He opens his parachute. That's, if you can't tell, that's a parachute and that's a man. And then he's now going at 1. And how long did this take? 6 seconds. So there must be a very big drag force that slows him down, but he still has his weight. So let's calculate the acceleration. U, V, A, T, S. U is 56, V is 1, A is what we want, and T is... So what will we go with? The same again. V equals U plus AT. So what's that? Minus 55 over 6. Yeah?
Yes.
Okay, I'll just leave it like this because I'm lazy. A is minus 55 over 6. We also know F equals MA. What's the F here? W minus drag, yeah, which is MA. So what does drag equal? W minus MA. What's W? Mg, isn't it?
Yeah.
Minus MA. Okay, so let's calculate the answer. What did I say his mass was?
60.
60?
Yeah.
Okay, now I'm taken down as positive, so I have to be very careful with my signs here. 9.81 minus 60, 55 over 6. This gives me the right signs because I'm going down as positive. I should take away this one here. So I want this to be positive and this to be negative. Is that the final one? Yeah. Well, let me check. What did you get?
You kept it as a fraction. You get.
Yeah. 38.6 newtons is what I got in the end. Is that what you got?
I got 57.8.
Maybe it's a rounding thing. It's very close, yeah. Maybe because I kept it as a fraction then, so yeah, don't worry about that. And then finally, part C. Do you think the drag will stay the same?
Increase.
You think it'll increase?
I'll take it open the parachute.
So I'm comparing the average drag for those 6 seconds and then his fall after that.
So it decreases.
I think it would decrease because what's going to happen is when he first opens the parachute, there's a lot of drag to slow him down, but then for the end, I can tell you exactly what his drag will equal for the rest of the journey. No, that's only for the 6 seconds.
Oh yeah.
For the rest of the journey, his drag will equal his weight.
This way, yeah.
60 plus the parachute.
No, it'll just equal his weight. Why am I saying this? Exactly. So the drag will only be 60 G. Yeah. Oh, so it'll actually be. Looks like it'll be more. 588. Anyway, the answer is: will it be the same? No. Okay.
Why?
Oh, did I say why?
Yeah.
Okay, right, yeah. Its velocity. Remember I said the drag depends on its velocity. So, its velocity is different. He's going, at the beginning he went from, what was it, 56 to 1. But then for the rest of the journey,
And it's 1 to 0.
well,
One only.
1, yeah. You know, I think I've made a sign mistake here.
Yeah, I think so.
Because this feels too small.
I got 1158.
This feels better. Hang on, let me think. I'm taking down as positive and up as negative.
Yeah.
Down, W minus drag should be positive.
Your
This
acceleration
is negative because
Yeah.
that's upwards. Yeah, so actually I'm sorry, I forgot the minus here. My sign is wrong. I should have kept the minus there. So if you got 38, it means you made the same mistake as me then. Plus, oh no, it'd be much bigger. It's just, I was expecting it to be really big because it's slowing them down a lot.
Yeah.
Yeah. So the answer is no. Here, what did we say his drag was? 60 G, wasn't it? So you can see that it reduces. So when he first opens the parachute, there's a lot of drag to slow him down, and then as he moves at a steady speed, it reduces. It's difficult, I know. Might have to do some more. Can I go to the next one? Can I go to number 2? Yeah. Number 2. I should have put number 2 first because it's easier. Oh well. It's recording, but I need to go on to 2. A bullet is fired upwards at a speed of 300. The terminal velocity is 150. How long until it hits the ground? Ignore the drag until the terminal velocity is reached. So, what I'm saying here is you have a bullet, it's fired at 300 meters per second. It will continue up until it reaches 0 meters per second, and then what will happen? It'll continue down. But what I'm saying is happening is it slows down when it's falling, so it will reach 150 at some point, and this 150 is terminal. Yeah. So what I should do is I should work out the time to go from here to here, and then it's a separate problem from here to here. Why?
Because the acceleration is 0.
Yeah, so this part is just a distance, speed, time triangle. There's no acceleration from here to here. Do you understand? Because it's at terminal velocity, which means constant velocity. So let's get the time from here to here. The U is what? 300. The V? No.
What was you?
No.
Like if you want to.
No. You're doing it his way. Don't do it his way. Do it my way. What's the V? No.
Wow.
Yeah. Going down. So minus 150. If you said 150, you would be getting the time from here to here only when it's going up. Yeah. A minus 9.81. T is what we want. S, do not know. What will give us the T with most ease? V. No. V equals U plus A. T. T equals 45. No, it's not realistic. No bullet stays this long in the air. Sorry. Maybe the sniper rifle. 45.9 seconds. Now, for this last part, we have distance, speed, time. So what's the time? Distance over speed. Do we know the speed? Yes. Do we know the distance for this part? No. But if we got the distance from the first part, we could maybe work it out. Because the distance from here to here will be the same as the distance from here to here. And in this part, it's plus 150 on the way up. So, U, V, A, T, S, everything is the same except the V is 150. So let's see what we get now. 150 minus 300. Oh wait, no, sorry, I want the S, don't I? So, what would be the best formula to give me the S here? V squared maybe? Yeah?
Yeah, V squared.
V squared equals U squared plus 2A S. Three kilometers. Yeah, very unrealistic.
It's a bullet.
Well, it's a sniper rifle. Could a sniper rifle go 3 kilometers?
Upwards, impossible. And this is only the way to 150. It still has more to fly.
Oh yeah, that's true. Maybe we'll make it a missile, perhaps. Yeah.
A rocket.
A rocket, yeah. 150 squared minus 300 squared divided by 2 divided by 9.81. Yeah, okay. Merely 3,440 meters for this part here. So this part here would be the same. So the time for the second part would be distance over speed. And what's the speed for this last part of the journey? What is it? 150. 22.9 seconds. So we take this and we add it to this. 68.8 seconds is the time. Very hard. I know, these are hard questions.
Is the exam going to be like that?
No, this would be maximum possible difficulty. If this wasn't the exam, it would be in section B, and they would break it down into steps for you to do. You know, like step 1, they'd ask you, part 1 be, what is the time from here to here? Part 2 is here, you know what I mean? So,
And how did you get this escape from?
I added the 2 times. From here to here, and then here to here.
That's really one of the maximum.
Wasn't that what I said? Was it?
Yeah.
Yeah. Okay, part 3. A 1,200 kilogram car accelerates to its top speed over 20 seconds. What is the drag force? Okay. Right, so we have our car, 1,200 kilograms, and it goes from 0 kilometers per hour, and it reaches its top speed. What did I say it was? 160? Is this my Toyota Yaris? Yes, this is my Toyota Yaris. 160 kilometers per hour. And this took 20 seconds. Okay, what should we do first? What should we do first? Anybody? First thing to do?
What do they want?
Doesn't matter. What should I do first?
Find new VTA.
Before that?
Yeah.
Here, 44.4 meters per second. And here, 0 meters per second. Now we do UV8, yes. U, 0, V, 44.4, A, don't know, T, 20, S, don't know. And what would I like to know? Well, the A. So what formula will work for me? Again, V, yeah, V equals U plus A T, so the A is 44.4 divided by 20. 2.22 meters per second squared. Okay. No, the car's accelerating. Yes. It starts from rest and goes faster. Okay. Now, what is providing this? It's the thrust of the engine. Okay? At the very end, it still has the same thrust. But what is the big difference at the end?
Drag.
There's a drag.
The same.
And very good, because it's reached its terminal velocity, so this here is also a T. Whereas here,
That's
a 0. So, this, I'll just call it D. You have F equals ma. Do we know the m? Yes. Do we know the a? Yes. And what's the f? The f is the thrust minus the average drag. Now, think about this. If the drag at the beginning is 0 and at the end it's t, what's the average of 0 and t? T over 2. So it's t minus t over 2 equals 1200, 2.22. So a half t equals 2664. So the thrust is equal to 5328 newtons, but the thrust is exactly what the drag is at the end. And now, do I ask you for the drag or do I ask for the average? What is the approximate drag force? I should have really said at the end, which I didn't. So I'll add that in. The answer is, this is the drag force at the end. Again, these are a bit more complicated than what you would have done in high school, possibly. Okay, so what we'll do is, there's one question left. We'll leave that one for our homework, for you to do something at home, because I don't like when you don't have homework. I know you don't like it either. And we'll do it in the next class, okay? So we'll just leave number 4 as a homework. Number 4 is like the ball being dropped in the beaker again. Question, yeah?
If you go back to the one section,
Yeah.
what's the T over the 2?
Yeah, the drag at the beginning is 0, and at the end is t.
Yeah.
So the average drag is t over 2, because it goes from 0 to t.
But isn't the T the thrust?
Yeah, but the thrust and the drag, they're equal at the end. Because I said in the question, the car reaches its top speed.
Okay, well what happens if I write D over 2 instead of T? Do I still get it wrong?
Where here? Or, no, in the formula?
Yeah.
No, d over 2 will be right, but then you must also say that d equals t, because your formula will have 2 unknowns in it. It will have a t, and it will have a d, and now you can't solve this equation. Does that make sense? It's like you need 2 equations then.
Just keep going.
Huh?
I just want to write.
Yeah, let me just fix something here so I don't forget. Here, is it? No, here. Guys, go get your food. I'll see you at 4 o'clock.
That's half T?
Yeah. So actually, I really should say here D, not T. Yeah. Closing this now.